Hello again everyone, new video here, absolute value function. Not a difficult one, but if you haven't seen it before, you'll think, what the hell is going on here? This is crazy. It's not really a crazy idea. It's actually very common in industry and the like to only want the positive values of something. Okay. For those doing physics as well, I'll use the example of speed and velocity. Numerically, they're the same. Just that velocity will give a direction as well, whereas speed, there's no need for direction. So those that are thinking ahead, you'll probably think, hang on, you're talking about scalar and vector quantities, and I am. A vector quantity has direction to it, a scalar quantity does not. A scalar is just the number. So absolute value function is a way of transferring some of that data from a vector quantity to a scalar quantity. You're just concerned about the number. The value of it, positive or negative, you're not worried about. Okay? So what are we doing? Well, let's start with the really simple. Y equals x or f of x equals x. Very simple. You can see it there. There's no big surprises to anyone doing specialist here that that is what y equals x looks like. If that surprises you, get out now, trust me. Now, if we're looking at the absolute value, that's what these two lines mean, the absolute value of f of x, well, that's going to be equal to the absolute value of x because that's the function I'm working with. And we define it like this. So we define it as a piecemeal function, two pieces to make the function. The first part, we're just going to call it x. We're just going to say, hey, if you're in this domain, just call it x. Don't do anything to it, all right? But if you're in this domain, the less than 0 domain, then you've got to do minus x. Okay? Now, let's talk about these domains for a minute. We did a test just recently, and a few people did the little bit of a guessy thing. They went, oh, I know something's meant to be here. And they kind of faintly put a line in thinking, oh, I'm not really sure where it's meant to be. Now, look, I get that. Now, think about this. If I did that, then I haven't defined this function for the full domain of x. I've missed something out. Okay? Now I need to define it for all real values. So if I was to do this, that's absolutely fine. Now I have defined all real values. But if I do this as well, then I've got two functions for the one value of x equals 0. Which one do I use? Well, in this case, in most cases, it's going to be the same number, but you've double defined a point. Okay, a point on the domain. You can't do that. So you could leave it like this, that's absolutely fine. Or you could leave it like this, that's absolutely fine. It doesn't matter which one you define it through because they will give the same value anyway. And assuming that whatever function you're doing gives the same value, it doesn't matter where you put it, okay? But don't put it on both, and don't put it on neither. It has to be on one. I'm going to leave mine like this for now. It doesn't really matter which way you go. So we're defining the absolute value of x in two parts. So this part here, this is really exactly the same as my original function. So that part there stays exactly where it is. But what this part is doing is saying whatever the answer is, make it positive. Well, really, get rid of the negative. Okay? So what are we doing? Well, here is negative 3. Okay? So if I was to take negative 3 and put it into this function, I would get negative 3 out. So on this function, the point is minus 3, 3. Minus 3, minus 3. But if I take minus 3 and put it into here, can you see how it would be negative 3? So therefore the answer would be positive 3, which would be there, wouldn't it? Now hopefully you can see if I did the same with minus 2 and the same with minus 1 and put them in here, it would be the negative of negative 2 making positive 2. Negative of negative 1 making positive 1. And hopefully you can see that this line is going to do that. So this is no longer in play. Let me dash that one out. That is no longer in play. The line actually does this. It bounces. And hopefully you can see that this point here, 0, 0, could be seen as on this one or on this one, meaning that that's why it doesn't matter where it is, because they get the same answer anyway. So the absolute value of x idea is really a line that's going to bounce. That's all. Doesn't have to be a line, but in this case it is. We'll work on the other ones in a minute. So if you see a function graphed and it's got a definite bounce in it, you're probably looking in something like absolute value. So you'll spot them pretty quickly. They're easy to spot. Okay? Doesn't have to be a 90 degree bounce. It can be other ones, because if this line was steeper, then it would go out being steeper. So it doesn't have to be 90 degrees in here, but a definite bounce in it. Let's look at some other ones. 2x plus 2. Well, let's graph that up first. So here's 2. A gradient of 2x means that it will have a y-intercept of 1. So that means my original line is going to be something like that. Now, because I want the absolute value, all of this part of it is no good to me. This is no good to me. I don't want this part. This is no longer there. So it's going to bounce. Now, have a look at this. Take this value of 2 here, swing it down to below, right? Take a value of minus 2. Now, if you take a straight line between that value and that value, you're going to get the bounced version, because the gradient here is the negative of the gradient here. So an easy way, you can put your ruler there. I'll try and do it by eye. Oh, that's not too bad. Because that line there would then go back through there. While we're on this point, let's talk about getting that other line. How do we get that other line? Well, this one is y equals 2x plus 2. Okay. Now, we know the point here. That point there is going to be minus 1, 0. And we would know that point as the opposite of that. So this one is going to be at 0, minus 2. So between those 2 points, we could get an equation for that. We could get an equation for that. But here's another way of doing it, is just take this guy and throw a negative into it. So this line here is going to be y equals minus 2x minus 2. And when you think, there's the minus 2 for the y-intercept, and the gradient's got to be the same as that guy, but just the opposite. So this here is the equation of that line. And that works exactly the same here, because y equals x, y equals negative x. So it just works the same. Jump over to this one. Now, I'll pause just for a moment. I want you to look at that in your mind, and I want you to say, how could I get an absolute value function of that one? Well, you already have. Because think about this. Doesn't this value, this function here, is always above the x-axis, isn't it? So this here, x minus 3, well, that's going to push him out here 3. And then the plus 2 is going to push him up 2. And because it's a positive quadratic, isn't that going to be something like that? So in this case, the graph of the absolute value of x and the graph of f of x is going to be exactly the same, because the range of f of x was only ever positive. And remember, the range of f of x, that's the thing we're trying to make into the positive, okay? Is the range is what we're trying to make into the positive. Notice, the range of this part of the function was only ever positive. The range of this part of the function, or the whole thing really, was only ever positive. So I'm going to change this question now. I'm going to change it. I'm going to do this. I'm going to go minus. Okay? Minus. So that would take that guy and flip him upside down, wouldn't it? Okay? So let's still move along 3. Okay, we move to here. The minus would put him this way and then moved up 2. So here's 2. This graph would look something like that now. Okay, follow the colour coding with the green. Now, if I want to graph the absolute value of f of x, well, this part from here to here, I leave exactly where it is. It's not going to change. But this part, I want to get rid of this guy and get rid of this guy, because that is going to go, so I'll try and get my line the right way. There we go. He's going to be something like that. Okay, something like that one. Because I don't want anything down here. Anything that is down here I'll flip back up. So just flip those arms up. Last one, sine of x. Now, back into trig, here we go. This is not really the right graph that I want. I'm going to draw another one for us. Because I'm going to do sine of x, and because sine is a cyclic function, I don't really need a Cartesian graph like this starting at 0. I really should do this, right? Because then I can say, well, here's 2 pi. I'll put pi about here. Therefore, pi on 2, 3 pi on 2 will be about there. And because it's sine of x, the amplitude is 1. So I'll go 1 and -1. Now, think of our unit circle. I'll get a little sketch in here. Unit circle, right? I might be backing up here for you. That's okay. So when I'm here at an angle of 0, the sine value is 0 as well. There we go. When I'm here at 90 degrees or pi on 2, the sine value is 1. So there's pi on 2, there's 1. When I'm here at pi, the value is back to 0. When I'm here at 3 pi on 2, I'm at -1, about here. And then I'm back to 0 at 2 pi, or I'm back to 0 again. Right. If you're ever worried about graphing these, come back to the original. That's where everything comes from. Okay, so now what I'm going to do is I'm going to do this. I'm going to draw in my graph. Let's go with green. So it'll be here, here, there, and there. Okay, that's not a bad sketch. I'll just cheat a little bit and move that up here. There we go. Right. Now, if I want to graph the absolute value of this, well, this part's fine. From 0 to pi on that diagram, it was all positive. So that's fine. But this is where it went negative. So I want to get rid of this guy, right? He's no longer there. And actually, he's just going to do that. Oh, that's a little high there, isn't it? He's just going to do, there we go. He's going to do that. So it's kind of just like humps. That's all. And if you did this forever, it's just going to be humps on the positive side. Okay? Now, what happens over here in the negative values of x? Well, exactly the same. This is going to be exactly the same. So the absolute value of x just has humps all the way along. Sorry, absolute value of sine of x. Now, if I did cosine of x, it's also going to be humps, but shifted along by pi on 2. Okay? If I did tan of x, well, you know, tan of x comes up like this. Well, this part is going to flip up, so it's actually going to come down to this and then back up. Do that on your calculator and see. You should be able to graph all of these on your calculator. There's a lot of fun to be had here playing around, graphing things and the like. Do play around, because it is kind of fun. Have some fun with your maths. But there's not a lot